This video looks at an example from the Leaving Cert higher level course using modulus or absolute value. Sketch the graph where f of x is equal to the absolute value of 2x minus 5 and hence solve the inequality that 2x minus 5 is less than 3. Well, to graph this, what we need is really 3 points. The most important point is the point where it cuts the x-axis, where f of x is equal to 0. And we see that this happens when x has the value of 5 over 2, because 2 times 5 over 2 minus 5 would be 0. The next point we might look at will be maybe either side of 5 over 2, which is 2.5. So, for instance, when x is equal to 0, then the absolute value is 5. And when x is equal to 4, the absolute value is 2 fours, which is 8 minus 5, which is 3. Now we're trying to graph these 3 points. Now we know that this is a linear modulus, so it kind of has a V shape. It's always above the x-axis. Just touches the x-axis at one place. So we're graphing this between, the x values are between 0 and 4. So let's just lay out our graph here. And the height here that we're interested in maybe will be up as far as 5. So the first point we see is 2.5 and 0. We have 0 and 5, and we have 4 and 3. So there's the 3 points. So you just take out your ruler and join these dots. And this V shape is a typical shape of this kind of linear modulus question. Now we're to ask, the question is, when is this less than the value of 3? Well, it equals the value of 3 at these points here, at the points 1 and 4. So where is it? Is the graph of this function less than 3? Well, if I just highlight it here, it's less than 3 at these points here. So we can see, looking at this, it's obviously between the values of 1 and 4 that the graph of this modulus is less than 3. So how do we write this answer then? We just say that the value of x is between 1 and 4, or x is greater than 1 but smaller than 4. And that's the solution to it. Now you could use this using algebra, the algebraic method either. The algebraic method, when dealing with an inequality, would be that you would square both sides. So this would get rid of the fact in the inequality whether one side was positive or negative. So you have 2x minus 5, the absolute value of that is less than 3. Now this would still be true if you square both sides. It doesn't change the inequality. So 2x minus 5 to be squared must be less than 3 to be squared. So if you square this, you get 4x squared minus 20x plus 25, and that must be less than 9. Just neaten this up by taking 9 from both sides. Now we divide both sides by 4. And what we do is we imagine if this inequality was equal to 0, then we'd have the solutions x equals 1 or x equals 4. Now what we do now is we test this to know is it inside or outside 1 or 4. So we put in x equals 0, that's just the simplest one to use, and we test it with the simplest inequality value we have, which is this one here. So x squared minus 5x plus 4. If we sub in 0 for x there, we have 0 squared minus 5 times 0 plus 4. Now the value of this is plus 4, and plus 4 is not smaller than 0. So that is not smaller than 0. So therefore 0, which is outside the range 1 and 4, doesn't work. So we know that our answer is not outside this range, so therefore it must be inside the range. So it must be between 1 and 4. So this is the same answer we got before, that x is greater than 1 but less than 4. And we just see that both our answers are the same.